Again, I come across these problems on the internet, and that's why I put these links down for you. This is find the values of A and B. Now, granted, sometimes with the letters they confuse students. I mean, if you put this down with X and Y, so you probably realize these are just parabolas that intersect, and they get intersect at 4 points, by the way. Now, when I say they intersect at 4 points, two of the points are going to be where the coordinate A equals B, or if it did X and Y, X equals Y. However, let me go to the whiteboard and write down what I'm seeing and see if I can solve this without understanding what these things are, just some simple manipulations of algebra, all right? So I'm gonna write it down for you, and there's two equations and two unknowns. So you have A squared minus B equals 43, and then you get B squared minus A equals 43. And what I'm gonna do is just subtract the equations. So like, for example, if I did this, two equations, two unknown, let me put this over right next to it. You can subtract these equations. What do you get? A squared minus B squared, and then you're going to get minus B plus A, and 43 minus 43 is 0. And then I start to realize that, this looks, it's factorable. And I factor by grouping. I factor these things by grouping. So the first two terms, A squared minus B squared, factors to A plus B, A minus B. And the next two terms, which is going to be minus B plus A, I could factor that as plus 1 times A minus B, and that equals 0, right? What do you do now? I would factor the common factor between the two terms now, which is A minus B. And what would you be left off with? Well, from the first term, you're left off with A plus B. From the second term, you're left off with 1, and that equals 0. Now, I'm going to use the zero product rule, and there's going to be two facts I know about. I know that A minus B is 0, or the A plus B plus 1 is equal to 0. Now, what does it say over here? A equals B. Now, if you look at the original condition of the problem, they said that A couldn't be equal to B. So this one needs to be crossed off as being extraneous. Now, this one over here, you say, what do you do with this over here? You either solve for A or B. I'm going to solve for A. What do you get for A? You get minus B minus 1. Again, someone can say, what did they want to know? They wanted to know A and B. So what I do is I take one of these equations and I plug it in. I want to do this one over here. And what do you get? You get A squared minus B equals 43. And I'm going to take this thing in here and I'm going to plug it in right over here. And what do you get? You're going to get minus B minus 1 squared minus B equals 43. All right, doesn't look too bad to do. Okay, let's square it. What do you get? You get B squared plus 2B plus 1 minus B equals 43. All right? What do you get now? B squared plus B minus 42 equals 0. Quadratic in form, by the way. What do you get over here? B, 0. I'm going to say 6 and 7, because 6 times 7 is 42, and they differ by 1. It's going to be plus 7 minus 6. Let's see if that works. You do get B squared. Minus 6 plus 7 is 1B, and you do get minus 42. So I got two B's. One B is minus 7, and the other B is going to be 6. But again, we're looking for where the values, for A and B, and I got the B now, and there's two values for that. And I want to remind you that A is equal to minus B minus 1. Put this on the side. A is minus B minus 1. So what's A in this case over here? Well, it's going to be 7 minus 1, which is 6. What's the A over here? It's going to be minus 6 minus 1, which is minus 7. And these are my two solutions over here. There's two, right? Either one works. But granted, if you want to graph these things out, I would recommend that you graph out, y squared minus b. I'm sorry, I'm going to x's, right? Sorry about that. Let me get my eraser out. So y squared minus x equals 43. And by the way, what I'm doing over here, I'm looking at a squared minus b equals 43. And the other one is going to be b squared minus a equals 43. And what do you write over there? You know what? I made a mistake in writing that now. Sorry, didn't realize that. A is going to be x. So I'll say x squared minus y equals 43. And what's this one over here going to be? Y squared minus x equals 43. So I'm really just saying, you know, instead of using the a, I'll use an x, and instead of using the b, I'll use a y. That's all I did, all right? What do these things look like? Well, it's going to be x squared minus 43 equals y, which I know is a parabola, by the way. And what's a parabola look like? It looks sort of like this over here. It's got a vertex way down here at 43, minus 43. What does this guy look like? Well, let's write down y squared minus 43 is equal to x. And that's also going to be a parabola where the vertex is going to be way over here, and it's going to do something like this over here. I'm sorry about that. You're not doing a great best job. You know what? Let me do a better job. Parabola looks like this, and a parabola looks like this over here. How many points of intersection you get? 1, 2, 3, 4. I want to point out where y equals x. That's where the x equals y over here. And they don't want that. We found these solutions over here. And what are they? Well, as ordered pairs, what are they? They're going to be, let's see, this is going to be 6, comma minus 7. This point over here would be minus 7, comma 6. And that's it. Thank you.